On August 17, 2017, a slow-moving tropical storm formed outside of the Gulf of Mexico. A day later, it hit the Windward Islands and weakened. Just a few days after, it was able to reform as a Category 1 hurricane known as Harvey. At the time, the wind speed was only about 80 miles per hour. As it churned towards Texas, it gained strength and wind power. By the time it made landfall near the Texas-Louisiana border on August 25th, it had become a Category 4 hurricane, with winds up to 130 miles per hour. So, how did Hurricane Harvey become so powerful so quickly? Well, what began as a smaller storm happened to pass over a region of extremely warm ocean water called an eddy. This spot of hot water was 1 to 2 degrees Fahrenheit warmer than the Gulf of Mexico around it, which itself was already warmer than usual. The hotter the water, the more energy drives into a storm. Harvey went from Category 1 to 4, practically overnight. With the storm came heavy precipitation. This caused Houston's 2 flood control reservoirs to breach, which resulted in heavy flooding throughout the area. Harvey's path was unusual because it lingered over Texas for about 4 days. Experts said that Harvey was stuck longer in one place than any other tropical storm in memory. Hurricanes are circular structures with spiraling winds, but they are steered by larger wind patterns in the atmosphere that push them around. In Harvey's case, a large, high-pressure system over the southeastern U.S. was trying to push the storm in one direction, but another big, high-pressure system over the southwestern U.S. was trying to push it in the opposite direction. These systems had equal strength and canceled each other out, so the storm was at a standstill. The Houston, Texas area has 2 reservoirs, Addicks and Barker, but neither of them were likely to hold the amount of water that was precipitated during Hurricane Harvey. So what was the cause of all of this flooding? Normally, a hurricane pulls moisture up from the ocean and releases it later as rain. But Harvey had dropped so much water over such a large area of Texas that the storm started pulling that water back up into itself and dumping it again as more rain. The flooded area acted like a part of an ocean, feeding warm moisture back up and into Harvey. Although the major damage was done to the Texas-Louisiana border area, the storm affected as many as 13 million people from Texas through Louisiana, Mississippi, Tennessee, and Kentucky. Many residents were forced to evacuate their homes and head for higher grounds. Over the course of the storm, at least 88 people died, and as many as 204,000 homes were affected. Many did not have flood insurance. The Federal Emergency Management Agency was able to deliver 80 tractor-trailer loads of emergency supplies to shelters and other affected areas. FEMA gave out $378 million in direct aid, but because of the extent of the damage, some of the lower-income residencies were denied compensation. Damages were estimated to be around $125 billion. This puts Harvey as the second most costly hurricane to hit the U.S. mainland since 1900. An updated floodplain map was released for Texans who prepare for regular flooding. But the best-known proposal for hurricane mitigation along the upper Texas coast is the coastal spine, also known as the Ike Dike, a concept borrowed from the Dutch, which would involve a line of coast barriers, levees, and gates to protect Galveston Bay and the Bolivar Peninsula. Flooding from Hurricane Harvey has also changed the way that city planners approach urban development. More pavement and more concrete leads to more runoff and thus more flooding. Over 166,000 acres in the area have been paved in the last 10 years, greatly increasing the flow of floodwater into bayous, reservoirs, and drainage systems. The temporary accumulation of water after a heavy rain is called a flood pool. Of the 10 largest U.S. flood pools built up after storms, 6 have occurred since 2000. City planners must take such factors into account when approving new development.